welcome back. Let's continue on here. We just finished the fourth root of 81 x to the 12th, which ends up being 3x to the third. Let's take a look at this problem now. The third root of 8, a to the ninth, b to the third. Okay, and I'm thinking on this one, I prefer to solve this, with the radical notation again. So I have the third root of all this stuff. 8, a to the ninth, b to the third, right? Now 8, 2, 2, 2. So I know the third root of 8 is 2, right? And then you got this a to the ninth, okay? Which is a to the third to the third, right? Again, if you got 3 sets of a to the third, you know the third root of a to the ninth must be a to the third, okay? Again, it's like you're matching, if you can match that and that type of deal, right? And then you got this b to the third. In other words, b, right? So you know b's got to come out. So you got third root, oh, I'm sorry. Just simplify that. So we got the 2, right? And we got 3 sets of a to the third, right? In other words, if you wrote out a, you got 9 a's, right? I can circle 3 sets of a's, right? So a and an a and an a are going to come out. And then you got this b, so you know a b is going to come out. And you actually have nothing left. So 2a to the third b, 2a cubed b. Okay? All right, 6th root of y to the 12th over x to the 24th. Let me just split this up since those are different variables here. So I have 6th root of y to the 12th. I get the 6th root of this x to the 24th, right? If I write out 12 y's, I'm looking for 6 of a kind, right? It's going to end up being I circle 6 y's. That means I'll take one y out, and then I'll circle another 6 y's. That means I'll take two y's out, right? So I'm left with y squared. So I have the 6th root, write it this way, and then right down here I want to again write it as x to the something to the 6th, right? And I'm trying to match that 24, hopefully have no leftovers, and I can. So x to the 4th to the 6th, and so I end up with on the top y squared, right? On the bottom here I'm going to end up with x to the 4th, y squared over x to the 4th here. All right here, so we had the 6th root of y to the 12th over x to the 24th is y squared over x to the 4th. Now let's look at, let's get another one here. Let me start new. Okay, so how about this problem here? You notice you got some x's on the top, you got some y's on the top and the bottom too. You only got that z squared in your numerator there. Okay, so let's first of all think about 8 over 4. Okay, so we got 2, right? And now we got a quotient here. We got that x squared over x to the 4th, right? So we can go ahead and do 2 minus a 4th. So we apply that quotient property. And then we got, you see the y to the 6 over the y to the 5th. So y to the 6 minus 5 on that one. And then we got the z squared. Okay? So we got 2, and remember x, 2 minus 1/4, right? So same thing as 8/4 minus 1/4, because 8/4 is 2. So we got the 7/4 there. And then y to the 6 minus 5, which is y to the 1, and then we got z squared. Okay, so 2x to the 7th 4, 2x to the 7/4, good grief, y z squared. Okay, done with that one there. All right, let's take a look. Write the expression again in simplest form. So we're going to write some variable expressions in simplest form here. So here's your example. Let me write this down first. Third root of y squared over x to the fifth. And we got, now we're going to assume that all variables here are positive. Okay. So you notice how you have, you got this x to the fifth here. Okay. Now on this, if you were to work this problem as is, right, you notice that you could break this up, third root of y squared, you get third root of x to the fifth, right? Let me write x, 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 right? We've got 5 of those. And I would take an x out here, right? Take an x out, and I'd be left with that x and x underneath, right there. In other words, x squared, right? Now, we got to rationalize this thing. In other words, we can't have, excuse me, a third root on the bottom. So what do we need to give this thing? So that we have 3 of a kind on the bottom, right? We already got 2. I'm like, well, I just need to give it one more x. So I'm going to multiply this thing by the third root of x. So on the bottom, I have the third root of x, 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 okay? But I can't just all of a sudden do that. I got to do it to the top, right? Because this is an expression. So I have to multiply this whole expression by third root of x over third root of x, which is 1. So I'm not changing anything per se. Okay, so now on the top, I got third root of y squared times x. I'll write that xy squared. On the bottom now, I have third root of x, 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 right? Isn't there 3 of those now underneath that third root if I put those 2 together? And then when I simplify that, I'll just have x and x. Okay, so you get the third root of xy squared all over x squared. Okay, that's how I'd go about doing that one. All right, you get, how about 3 third root of x minus a 1 third root of x? Like radicals, 2 third root of x's, right? How about, let's do another one. How about 5 x squared y to the 1/2 plus 7x squared y to the 1/2. You notice that the variables are the same. The powers are the same, right? It's x squared y to the 1/2. Both of them have x squared y to the 1/2. So 5x squared y to the 1/2 plus 7x squared square root of y is 12x squared square root of y. We'll leave it in exponential notation there. And that's it. Thanks for listening. See you guys in class.